So too, inside the egg-shaped storage vessel, cyclical spiral vitalizing movement of the water will be induced. Movement is an expression of energy, and energy is synonymous with life. The external evaporation causes cooling of the outer walls and the water in their immediate vicinity. Being cooler and therefore denser, this water becomes specifically heavier and sinks down along the walls towards the bottom, at the same time forcing the water there to rise up the center and move towards the outside walls. Continual repetition of this process results in the constant circulation and cooling of the contents. Having discussed the above ideal storage vessel, and in view of the fact that they are presently not available on the market, it would be a sorry omission if methods of improving existing installations were not also addressed. The main factor to be taken into account here is that of exposure to light and heat. Where possible, all above groundwater tanks, whether of galvanized iron, fiberglass, or concrete, should be insulated on all sides and external surfaces through the application of sprayed foam or equivalent thermal barrier to a minimum thickness of 75 millimeters. If not already white or of a light heat reflecting color, then it should be so painted. For in-ground tanks, the top surface only need be insulated and rendered white in color. For many people, dams or rivers provide the main source of water, and certain simple measures can be taken to improve the quality of the water obtained from them. Providing the surrounding soil is not impervious to water, a hole of suitable dimension, depth, and capacity, say 1,000 to 2,000 liters, should be dug about 5 to 10 meters from the banks of the dam or river. If possible, the depth should be equal to the depth of the latter. Wells dug next to dams should be situated above the highest water level. If the consistency of the soil is permeable enough, then water will percolate through the intervening soil and into the newly excavated well. Depending on the stability and load-bearing capacity of the soil, a structural engineer should be consulted there if there is any doubt. A small concrete perimeter footing should be placed at a safe and stable distance from the rim of the well. When the concrete has cured and set firmly, then a minimum of one course of block should be laid to prevent the entry of any surface water. In the case of wells next to rivers, however, it may be necessary to raise the height of the blockwork to just above the average height of estuary, to raise the height of the blockwork to just above the average height of floodwaters, to prevent contamination of the well water during floods. The well should then be totally enclosed and sealed with a well-insulated timber and sheet metal roof or a concrete slab, and provided with an access hatch to service the pump and or suction pipe and foot valve. Preferably, the pump should be located outside the well space to avoid any possible oil pollution, etc. The reason for having the 1,000 to 2,000 liter storage capacity mentioned earlier is that it may only be possible to pump water intermittently, because the rate of replenishment from the main water source may be fairly slow, depending on the permeability of the soil. In the event that the soil surrounding a dam or a river is impervious, then it would be necessary to excavate a channel about 600 millimeters wide between the well and the main water body. The lower part of this should be filled with clean quartz sand to a depth of about 600 millimeters, and the upper part backfilled with the excavated material and compacted. As the water percolates through either the existing soil or the in-place sand, most suspended matter will be filtered out. Also, because the water comes into the well at the lowest level from the main water source, it will be as cool as possible under the prevailing conditions. In this state, it is less likely to harbor harmful pathogenic bacteria, which tend to populate the upper, more highly oxygenated strata of the main water body. The use of this technique on the author's own property produced an extremely clear, clean, odorless, and good-tasting water. Despite all outward appearances, however, it is still advisable to have such water tested by the responsible authorities for quality, purity, and any possible contaminants. In terms of its mineral, salt, and trace element content, river water would generally be far richer than tank water. As for the immature and mature water discussed at the beginning, in most cases it would be necessary to supplement the mineral content of rainwater. If this is the only source of drinking water, in order to prevent the extraction of these from the body of the drinker, here the suspension of an artificial fiber sac containing the dust of crushed basalt or other igneous rock used for road building, commonly known as crusher dust, would do much to enhance the composition of the tank water because it will hungrily absorb those elements it requires to become mature. However, before adding any crusher dust to the water, it would be again advisable to test the resulting change in the quality by analyzing the difference between two samples of tank water, one with crusher dust added and one without, as a control. Both samples should then be placed in a cool, dark place and left for at least a week before analysis of the mineral content, bacterial purity, etc. is carried out. This should be done by a suitably qualified specialist. These suggestions for improving water quality are the result of my personal experience and understanding of Viktor Schauberger's pioneering discoveries and theories. Viktor Schauberger's great dictum frequently asserted was C squared, comprehend and copy nature. For it was only thus that humanity could emerge from its present crisis-stricken condition. They call me deranged. The hope is that they are right. It is of no greater or lesser import for yet another fool to wander this earth. But if I am right and science is wrong, then may the Lord God have mercy on mankind. Indeed, at the Stuttgart University of Technology, West Germany, in 1952, these theories were tested under strict scientific and laboratory conditions by Professor Dr. Ing Franz Popel, a hydraulic specialist. These tests showed that when water is allowed to flow in its naturally ordained manner, it actually generates certain energies, ultimately achieving a condition that could be termed negative friction. Checked and double-checked. This well-documented but largely unpublicized pioneering discovery not only vindicated Viktor Schauberger's theories, it also overturned the hitherto scientifically sacred second law of thermodynamics, in which, without further or continuous input of energy, all systems must degenerate into a condition of total chaos or entropy. These experiments prove that this law, whilst it applies to all mechanical systems, does not apply wholly to living organisms. As a result of these discoveries, it was arranged that Viktor Schauberger be taken to the United States in 1958, where sums amounting potentially to many millions of dollars could be made available as start capital for a Los Alamos-like venture to develop Viktor Schauberger's theories of implosion. He was accompanied by his son Walter Schauberger, a physicist and mathematician, to assist in the scientific interpretation of his father's theories. Soon after arrival, however, various misunderstandings developed, too complex to elaborate here, whereupon Viktor Schauberger fell silent and refused to participate. After some 3 months of silence, the project was abandoned. Viktor and Walter Schauberger were then permitted to return to Austria, where Viktor died in Linz some 5 days later on the 25th September 1958, a very disillusioned man. On their return journey, Viktor asked Walter to translate his theories of implosion into terms of physics, geometry, and mathematics in such manner that their veracity was irrefutable. Because Viktor Schauberger's concepts broke new ground, this presented some difficulty. There was no adequate scientific terminology to describe them, nor was there any mathematical basis from which the necessary shapes could be precisely defined or constructed. With his own devices and apparatuses, Viktor Schauberger had also encountered problems of construction, which in part affected the optimum functioning of these machines, because the state and sophistication of the technology then available was inadequate and too cumbersome to build them properly and accurately. The vital development of a new technology harmonious and conforming to nature's laws demands a radical and fundamental change in our way of thinking and to our approach to the interpretation of the established doctrines and facts of physics, chemistry, agriculture, forestry, and water management. As a pointer to how such a new technology should come about, let me quote Viktor Schauberger once more. How else should it be done then? Was always the immediate question. The answer is simple. Exactly in the opposite way that it is done today. Callum Coates, August 1997. The nature of water. Viktor Schauberger's overriding passion was the quality of water and the way he perceived that it was being destroyed by contemporary mechanical means. In particular, he raged against what he saw as the devastation of the world's once sparkling, vibrant, great rivers by insensitive hydrologists and river engineers. Driven by the increasing urgency of making these fateful errors known to the public, he wrote The Nature of Water and a number of other sections in this book between 1932 and 1933. These were originally published in a two-part book entitled Our Senseless Toil, The Cause of the World Crisis. For Viktor, the publication of this, the largest of his individual works, became imperative due to the untimely death in 1931 of Professor Philip Forkemeyer. Forkemeyer was a hydrologist of world repute who sponsored the publication of a series of Viktor's treatises on all aspects of water in Die Wasserwissenschaft, the Austrian Journal of Hydrology. Without Forkemeyer's vital and continuing support, the publication of his comprehensive exposition came to an abrupt end, as is examined at greater length in the main section entitled Temperature and the Movement of Water. The upholder of the cycles which sustain all life is water. In every drop of water dwells a deity, whom indeed we all serve. There also dwells life, the soul of the primal substance, water, whose boundaries and banks are the capillaries that guide it, and in which it circulates. Every pulse, beat arising through the interaction of will and resistance is indicative of creative work, and urges us to care for those vessels, those primary and most vital structures in which throbs the product of a dualistic power, life. Every waterway is an artery of this life, an artery that creates its own pathways and bridges as it advances so as to diffuse its dawning life force through the earth and elevate itself to great heights to become shining. Beautiful and free, standing at the highest level of evolution, and above all being blessed with mind and reason, humanity constantly does the most idiotic thing imaginable by trying to regulate these waterways by means of their banks, by influencing the flow mechanically instead of taking into account the fact that water is itself a living entity. The basic teaching of the Ionic natural philosopher Thales, 625 to 545 BC. Water is the source of all life, embodies a profound understanding, and is of a great importance. It should in no way be construed as idle speculation. As a Greek, he had intuition which, according to Gothi is a revelation emanating from the inner self. Intuition is spiritual seeing, not an insight gained through experience or rational thought. According to Spinoza, it is the highest form of perception because the pure principles of nature alone remain active and the categorizing propensity of the human mind does not come into action. It is therefore unable to perceive the world as a multiplex unitas and necessarily creates a highly incomplete picture. Standing at the highest level of evolution, and above all being blessed with mind and reason, humanity constantly does the most idiotic thing imaginable by trying to regulate these waterways by means of their banks, by influencing the flow mechanically, instead of taking into account the fact that water is itself a living entity. The assumption behind this absurd practice is that riverbank shapes the water course, whereas the riverbank is actually the secondary effect and water the primary. To regulate water by means of the riverbank is truly to fight cause with effect. It should be as inconceivable to a thinking engineer to reinforce the crumbling bank of a watercourse with rammed piles and brushwood bales, or to smear over cracks with cement, as it would be for a doctor to patch up ruptured capillaries with needle and thread. Astonishingly, though, it still happens. The condition of all our waterways demonstrates just where these measures have led. In not one single case has the desired object been attained, namely the achievement of a normal channel profile. On the contrary, all such river regulation has provoked further damage which far outweighs any local or short-term advantages. Large rivers such as the Danube, Rhine, Tagliamento, Esch, Garane, and Mississippi bear witness to the failure of such complicated and costly river regulations. Quite apart from the tremendous damage caused in the lower reaches by their strictly mechanical regulation, these rivers are stripped of their most valuable assets, their great physical qualities. The present dirty, gray, muddy brew known as the Blue Danube, upon whose bed river gold once gleamed, and the Rhine, the symbol of the German identity, where Rheingold flashed in bygone days, are tragic testimonials to these perverse practices. The mythical gold of the Nibelungs originated in the golden glow given off by pebbles as they rubbed against each other while rolling along the riverbed at night. For when there is a decrease in water temperature, the attractive force increases, causing the stones to move. If two pebbles are rubbed together under water, a golden glow appears. This yellowish red fiery glow used to be mistaken for the flashing of gold, thought to be lying on the bottom of the river. Today, this river gold lies heaped up in huge mounds of gravel, shifted hither and thither by the force of the sluggish and murky water masses flowing above them. Tractive force. This refers to the force described hydraulically as shear force, the force that acts to shear off or to dredge and dislodge sediment. In German, the term for shear force is Schubkraft, meaning to push, to shove, as well as to shear, whereas Viktor Schauberger uses the word Schleppkraft. The verb schleppen means to drag, draw, or pull. Viktor Schauberger's choice of Schleppkraft here is quite specific, since in his view the movement of sediment is due to the sucking action of fast-flowing dense cold water downstream rather than to the mechanical impact of the water coming from upstream. In view of this subtle change in emphasis, In lieu of the hydraulically correct term shear force, the term tractive force will be used. This dynamic is similar to the effect of wind on roofs, where a roof is blown off not by force from the windward side, but rather by the sucking effect of vortices created on the leeward side. They no longer imbue the water with energy and soul as once they did. Instead, they assist in ousting the soulless body, water, from its badly regulated course. Our clear coat mountain streams have become wild torrents, full of the vigor of youth. These lively streams used to be surrounded by burgeoning vegetation and consorted with every blade of grass as long as man did not interfere. Today, they can no longer be confined even with meter-thick concrete walls. Wherever we look, we see the dreadful disintegration of the very